Hi guys, today I will be solving a composite great circle sailing question, but with a twist here. The two positions will be in two different hemispheres. This has not been done before, so I thought I should make a video on it as well. So the question is, calculate the composite great circle distance between the position A, which is 30 degrees north, 150 degrees west, and position B, which is 10 degrees south and 10 degrees east, with a limiting latitude of 37 degrees north. All right, so let's get started. The first thing we will be doing is drawing the diagram, which is very important in such questions because we have to get our concepts right. So when we draw the diagram, the first step is we look at the two latitudes. So in this case, the two latitudes, one is in north and the other is in south. So we look at the latitude of a higher value, which in this case is 30 degrees. North is the higher value, so you will choose the pole of the latitude with the higher value. So this is, in this case, of course, north is high, so I will draw this diagram with respect to the north pole. The next thing you have to do is determine the d long, or the difference in longitude between the two positions. So in this case, the difference in longitude between the two positions, if I can write so here, longitude A is 150 degrees 00 minutes west, and longitude B is 010 degrees 00 minutes east. Now the d long will determine the shortest distance here. So here, opposite names, d long, you will add the two together, so this becomes 160 degrees. Direction is not important at this moment. So 160 degrees, but going from west to east, you are of course going in an easterly direction. So if it is less than 180, that means the diagram can be drawn with respect to the prime meridian, or the Greenwich meridian, or the meridian of 000 degrees. That means your west will come on the left hand side and east will come on the right hand side. So now, knowing this, I will draw the diagram. So north pole, I go west on my left hand side, 30 degrees north, and I go east on my right hand side, and I stop at 10 degrees south. So I'm just trying to make it into a little bit of an exaggeration so that it's easy for us to understand what is happening here. So of course these drawings are not to scale, it's just for our understanding. And then we will join these two lines together as well. All right, so this is A and this is B, and we can call them these two vertices, of course, vertex. All right, and latitude of A is of course 30 degrees north and longitude is 150 degrees west. Latitude of B is 10 degrees south and longitude is 010 degrees east. Latitude of the vertex, or the limiting latitude, is 37 degrees north, so I will draw this here. And the total d long is this angle P here, 160 degrees. This is what we have found out, isn't it? So the d long angle P is the angle subtended by the meridians, or the longitudes, passing through the positions A and B. So the total angle P here between A and B is 160 degrees. That's the d long between A and B. So what else can I find out here? So remember, B has gone below the equator, so I will put it below the equator here. All right, so PA, in this case, PA, what is PA? Now remember, from pole to the equator is 90 degrees. So from P to equator is 90 degrees, and from A to equator is of course the latitude of A, 30 degrees north. So PA would be 90 degrees minus 30 degrees, which is equal to 60 degrees. All right, so from pole to the equator is 90 degrees. From A to the equator is the latitude of A, which is 30 degrees. So naturally PA would be 90 minus 30. Now look at PB. What is PB? PB is nothing but 90 degrees. So from pole to the equator is 90 degrees. And then from equator to B is the latitude of B, which is 10 degrees. So I will add this 10 degrees here, and this becomes 100 degrees. So PB goes from P to the equator first, that is 90 degrees, and then from equator to B, which is 10 degrees. So I will add this and it will become 90 plus 10, which is 100 degrees. And similarly to PA, PV and PW would be 90 minus 37, which is 53 degrees. So PV equals PW, and PV and PW, PV equals PW, which is equal to nothing but 90 minus 37 degrees, which is equal to 53 degrees. This is similar to PA, because from pole to the equator is 90, and from the V and point W, which is the limiting latitude, this is latitude along which the vessel will do parallel sailing. This is one same latitude of 37 degrees north, so that is 37. So from V and W to the equator is 37. So PV or PW should be 90 minus 37, which is 53 degrees. So knowing these information, I will solve triangle 1 first. Remember, the vertex form a subtend a 90 degree angle, because that is when the arc goes flat. And then I will solve triangle 2, and then I'll come to triangle PVW or triangle 3. All right, so let's solve triangle PAV first. So if you look at triangle PAV, and I will use Napier's diagram, because in triangle PAV I've got a 90 degree angle, so I can use Napier's. So I will use Napier's here. So PAV, top semicircle 2 halves, bottom semicircle 3 parts. Put the 90 degree angle outside the circle, V equals 90 degree. Then put the sides next to the 90 degree angle now. So AV and PV. Then the angle opposite to AV is 90 minus P, and the angle opposite to PV is 90 minus A, and then put the remaining side 90 minus PA. All right, this is the using the Napier's rules. So what do I know here? I know PA and I know PV, and what I will find out is firstly AV. So how do I find out AV? So I will use the rule of cosine. So as you can see, I will use the rule of cosine, because the two things that I know and the one that I don't know are in the rule of opposites here, so they are not adjacent to one another. So I will use the rule of cosines here. So this becomes sine of mid part, which is sine of 90 minus PA, equals cos of AV and cos of PV. So if the two that I know and the one that I don't know were adjacent to each other, I would use the rule of tan of adjacents. But if they are opposite, like in this case here, I will use the rule of cosines. So this becomes cos PA, of course. Sine of 90 minus PA is also equal to cos PA, in case you didn't know that. And then this is cos AV and cos PV. Cos AV is what I don't know, so I will keep it on one side here and take this to the other. So this becomes cos of AV equals cos of PA divided by cos of PV. Or you can just say cos of PA, which is cos 60 degrees, divided by cos of PV, which is 53 degrees, which in this case is 0.83082. This is cos AV. So AV equals 33 degrees 49 minutes. Now remember, AV is a unit of distance, so I want this in form of a distance, so I will just multiply it by 60 and I will get 2029 nautical miles. So that is my first distance done, which is AV 2029. So I can just put here 2029 nautical miles. I also want to find out angle P in triangle PAV. So this is angle PAV. I want to find out angle P here as well. It will make sense to me towards the end, but I will not use AV, the one that I just found out. I will still use the one that I had before. So I will use PV and 90 minus PA. Now the two things that I know and the one that I don't know are right adjacent to one another. So I will use the rule of tan of adjacent. So in this case, the rule will become sine of 90 minus P equals tan of PV and tan of 90 minus PA. So sine of 90 minus P can also be written as cos P, and this is tan of PV, which is tan of 53 degrees, and this is tan of 90 minus PA. So 90 minus PA is 60 degrees. So you can write this as here, tan of 53 degrees multiplied by, solve the bracket, tan of 30 degrees, which is nothing but equal to 0.76617 cos of P. So P here becomes 39 degrees 59.3 minutes. Now, so that I don't confuse this P with the big angle P, the big angle P being the angle P between A and B, I will call this P1. P1 is the D long between position A and the vertex V. Alright, I'll keep a note of this. I'll revisit this later. Now I have solved triangle 1. I will go to triangle 2, which is PBW. So look at triangle PBW. W is the 90 degree angle here. Alright, so make a note of this and then I'll continue. So in triangle PBW, I will again make a Napier's diagram. So triangle PBW, W comes outside the circle as 90 degree angle, right? And then the sides next to the 90 degree angle is PW and BW. The angle opposite PW is 90 minus B, the angle opposite BW is 90 minus P, and then the remaining side is 90 minus PB. Now what are the things I know? 90 minus PB, and I know PW as well. The first thing I want to find out is the distance BW. So using the two that I know, I will find out the one that I don't know. Now they are not adjacent to one another, so I will use the rule of cosine. So sine of 90 minus PB becomes the mid part, and what is opposited? Cos of PW multiplied by cos of BW. Now sine of 90 minus PB can also be written as cos of PB, and this is still cos of PW and cos of BW. Now BW is the one I want to find out. Did I just write BW or did I write W? So I will keep this unknown here and I will take this to the other side here. So cos of BW then becomes equal to cos of PB divided by cos of PW, which is nothing but cos of PB is 100 degrees divided by cos of 53 degrees, which is negative 0.28854. Alright, this is cos BW. Shift cos BW equals 106 degrees 46.2 minutes. But I don't want this in degrees and minutes. I want BW in distance. So I will multiply this by 60 and I get 6406.2. So BW, which is the second distance, is 6406.2 nautical miles. So I will go back to my diagram here and I will put that here, 6406.2, 6406.2. Now in this triangle, I will also find out P2, this angle here, the D long between the position B and the vertex W. So I have already found out P1 and I will find out P2 as well. So how do I do that? I will need to find this out using the two that I knew from before. So you can see PW, 90 minus P and 90 minus PB are adjacent to one another. So I will use the rule of adjacent. I will not use BW because I've just found out BW. So if I have made a mistake here, I don't want to carry this mistake forward. So I will use sine 90 minus P as mid part, and then tan of adjacent, which is tan of PW, multiplied by tan of 90 minus PB. Sine of 90 minus P can also be written as cos P, and tan of PW is 50, and tan of 90 minus PB is 100 degrees. So this can also be written as cos of P equals tan of 53 degrees multiplied by tan of negative 10 degrees, which is equal to cos of P equal to negative 0.23399 and P is equal to 103 degrees 31.9 minutes. I will call it P2 in this case because this is the D long between position B and W. Alright, now if I go back here, I have found out P1 and I have found out P2, and I know the total angle P was 160 degrees. So how can I find out P3? P3 is the D long between the vertex and V and the vertex W. So what I will do is, I've got P equals P1 plus P2 plus, so P equaled 160 degrees, P1 was 39 degrees 59.3 minutes, P2 was 103 degrees 1.9 minutes, and P3 is my unknown, right? So all I have to do is just subtract 160 degrees minus 39 degrees 59.3 minutes plus 103 degrees 31.9 minutes. So P3 comes out to be 6 minutes. Now this P3 is nothing but the D long between V and W. So if I go back to the diagram, if I have found out the D long using the principles of parallel sailing, I can find the east-west distance VW, because this becomes departure. Departure equals D long multiplied by cos of the latitude. D long I've just found out is P3. So D long between V and W is P3, but I need to use the formula here. Departure equals D long cos of latitude. Now this D long has to be in minutes. So I will convert P3 in minutes by multiplying it by 60. I get 988.8. I will put 988.8 minutes multiplied by cos of the latitude 37 degrees, because of which I get 789.7. So this is nothing but the east-west distance VW. VW 789.7 nautical miles. So now the distance AB can be written as AV plus VW plus BW, which means AV I know already is 2029 miles. Alright, so I thought I'll show you this new type of a question where the two latitudes are in two different hemispheres. The principle remains the same, except that you have to be very careful in the very beginning when you're drawing the diagram and the way you find out the PB in this case, where you have to add and not subtract from 90. Alright, let me know if you have any questions. I will try my best to answer them as soon as possible. Good luck with your studies and see you soon.